Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 12th. Mathematics class 12th, we have been seeing inverse trigonometric functions. We have seen exercise 2.1 and now is the turn of exercise 2.2. We'll see all the questions of exercise 2.2 one by one. There are a lot of questions in exercise 2.2. It is a very important exercise based on the properties of inverse trigonometric functions. Yes, you should be aware of all the properties, interconversions, and not only that, interconversions in terms of multiple and submultiple angles as well. All of those things are important and those things will be discussed with you over here. Maybe before this you should have studied the domain, range, graph and all related to exercise 2.1 as well. Revise those things properly and then we'll see the questions over here. Let's take a look at this first question. What does the question say? Prove the following: 3 times sine inverse x is equal to sine inverse of 3x minus 4x cube. Now what's the important thing in this? Let's take a look at this. The important thing in this question is that this expression over here is something similar to this expression over here is what we know. What do we know? We know that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Okay, this is something that we are already aware of. This is a formula of sine 3 theta, yes. Okay, this is something which we studied in class 11th, yes. Okay, so will this formula be useful over here? Yes, you observe that 3 times sine theta minus 4 times sine cube theta. 3 times something minus 4 times that something cubed. 3 times something minus 4 times that something cubed, or 3x minus 4x cubed, wherein you can observe that this x can be substituted as sine theta. This x can be substituted as sine theta, right? Let's observe. X can be substituted as sine theta, or you can observe this also, x equals sine theta, or instead of that can you say that sine inverse x is equal to theta. Can you observe this, right? And this is the substitution that we are looking at. This is the substitution that we have to make on the basis of this analysis up till now. So the first thing that I do is let sine inverse x equals theta, where one important thing is already known. What is that? This is the interval in which x lies. This is the interval in which x lies. Let's write that interval as well, where minus 1 by 2 is less than equal to x is less than equal to 1 by 2. This is given to me. I am substituting this sine inverse x as theta, where x is already in the interval, already given lying in the interval minus 1 by 2 to 1 by 2. Benefit of this, let's observe. Once this is known, then can you also guess the values of theta from here? Yes. Where minus 1 by 2 is less than equal to x is less than equal to 1 by 2, what can you comment about the values of sine inverse x? This gives me sine inverse x is less than equal to and greater than equal to. Sine inverse x is also increasing, right? Is an increasing function, therefore sine inverse 1 by 2 will come over here. Sine inverse minus 1 by 2 will come over here. What is the value of sine inverse 1 by 2? Sine inverse 1 by 2 is simply pi by 6. That's the value of sine inverse pi by 1 by 2. And what is sine inverse minus 1 by 2? This is minus pi by 6 over here. Okay. So now we are aware of the values of theta as well. Okay. Therefore, theta is less than equal to pi by 6, greater than equal to minus pi by 6. Now, why are we doing all of these things? There's an important reason for that. But the reason I'll explain after a few steps. You will realize that why are we doing this after a few steps, but this is important. We started with the values of x that is given to us and we found the values of theta, that is from minus pi by 6 to pi by 6. This step is important. This step could have been done later. No, this step has to be done right now. And once you have substituted sine inverse x equal to theta, where theta is from this to this interval, then now we begin with this complicated expression over here. Let's begin with this. By the way, this gives me x equals sine theta. This gives me x equals sine theta. Yes. Now begin with this complicated expression. Sine inverse 3x minus 4x cube is equal to what? This is equal to, let's write it over here. This is equal to sine inverse 3 sine theta minus 4 sine cube theta. Because we've used a substitution over here in terms of theta, x is simply sine theta. Let's replace this x by sine theta. Benefit of this is this can be written as sine inverse sine 3 theta. Using that we can write it in this manner, right? Is that okay? Yes, that's pretty simple. Is there any issue in this? No, there is no issue up till now. What else? Now, remember one more thing from the properties of IDF. What should we remember? We should remember that sine inverse sine x, that is t inverse of t. We have learned how to define t inverse of t, and this is simply equal to x, but there is a condition. What's the condition? That x must be less than equal to pi by 2 and greater than equal to minus pi by 2. Only if x lies in this interval, this is the output. If x will not lie in this interval, then some of you may recall some things which you have studied while preparing for the JEE or somewhere else maybe, that this particular expression, this sine inverse sine x, has a periodic graph, and different definitions can be found in different intervals. I'm just giving a glimpse of that kind of a graph, sine inverse sine x. For minus pi by 2 to pi by 2, this is the graph. Beyond pi by 2, the graph goes like this, up till 3 pi by 2. Then the graph goes like this, up till 5 pi by 2. What's the intercept over here? The intercept, can you observe that this here is 0, this is pi, this is 2 pi, and so on and so forth. This here will be minus pi. What about this topmost point? This topmost point will be at minus 3 pi by 2. This is the graph, and from here you can note the definitions in different intervals. But do we actually require all of those definitions over here? The NCERT people have made your life very easy in this case. How have they made your life very easy? Please observe that sine inverse sine 3 theta, and where does 3 theta lie? If you observe carefully, 3 theta will lie in the interval minus pi by 2 to pi by 2. Sine inverse sine x, where x lies from minus pi by 2 to pi by 2. Yes, the output will be simply x. And how have they ensured that you only focus on that definition? Is by giving you the values of x. From x, we got the values of theta. Yes, you said that you will express the use of this calculation. Yes, I have expressed the use of this calculation over here. Since theta belongs to minus pi by 6 to pi by 6, we can observe that 3 theta is between minus pi by 2 to pi by 2. Had 3 theta lied in another interval, let us say pi by 2 to 3 pi by 2, we would have used this definition. Okay, what is this definition over here? This definition over here. Let's first write this definition. This definition is pretty simple. This is sine inverse sine x. If the graph is of y is equal to sine inverse sine x, then this line is actually y equals to x. It's pretty simple. What about the other line, the next line over here? This line over here is y equals pi minus x. This equation of a straight line is not a difficult thing, right? Equation of straight line is pretty simple. This is y is equal to pi minus x. Similarly, that here has another definition. This here has another definition. Right. Let's come back to this question and complete this question now. Sine inverse sine 3 theta for 3 theta lies in this interval will be equal to simply 3 theta. But did we start with theta? Were we given theta in the question? No. Can we leave the answer in terms of theta? No. We will have to leave the answer in terms of x. Now what is theta equal to? Theta is equal to sine inverse x. This is 3 sine inverse x. So we began with this and we reached this. Yes. That's a complete proof. Let me reiterate the important concepts and the important points which I have written on the right hand side for you. The proof is only this much. But a lot of things are involved over here, beginning from this formula to this kind of a substitution. We were interested in this kind of a substitution. So what do we actually substitute is this. Who can we not substitute this directly? If you substitute this directly, you will not be able to note this, this and this further, on the basis of which you get this. for your board examination, many times, this analysis over here is assumed that, okay, you know it, right? This is the complete solution, what you call the complete logical explanation of why is this happening in this manner and why are we not using pi minus 3 theta or 3 theta minus pi over here, right? Why are we not using pi minus 3 theta or minus pi minus 3 theta over here? Although this particular expression will be equal to various definitions in terms of 3 sin inverse x in general. Ooh, will it be equal to various other definitions as well? Yes, it will be equal to various other definitions as well, and I can explain those things as well to you. If you are interested in going further beyond this, then you can continue this question further. Otherwise, you can move on to the next question. By the way, what are we trying to deal with over here is, I want to simplify this expression, sin inverse 3x minus 4x cube. Now the initial steps will be same, this and this will be same, but herein the value of x will not be from minus 1 by 2 to 1 by 2, that has been given to us. We'll consider x from minus 1 to 1, okay. Sin inverse x will lie from minus pi by 2 to pi by 2, and this will lie from minus 3 pi by 2 to 3 pi by 2, yes. This will remain same, and at this stage you'll realize that 3 theta lies from minus 3 pi by 2 to 3 pi by 2. So in this interval, remember the graph, yes, minus 3 pi by 2, pi by 2, pi by 2, sorry, this is minus pi by 2 and this is 3 pi by 2, will actually get 3 different definitions, yes. One definition is this, the other is this, and the third is this. What are these definitions? This is y equals x, this is y equals pi minus x, this is y equals minus pi minus x. So major analysis is same except for this calculation over here, which will make a difference over here. This remains same. What happens to sin inverse sin 3 theta? The value of sin inverse sin 3 theta will be equal to minus pi minus 3 theta, that is minus pi minus x. This can be equal to 3 theta, or this can be equal to pi minus 3 theta. Pi minus x will imply pi minus 3 theta when 3 theta, that is this 3 theta lies in this interval minus pi by 2 to pi by 2. Before this, in this interval, minus 3 pi by 2 is less than equal to 3 theta is less than pi by 2, you get this definition. In the interval after this, you get another definition. What's that? Pi by 2 is less than 3 theta is less than equal to 3 pi by 2. Okay. So different definitions in different intervals. And now you can observe one more thing, that these people are pretty smart. They've chosen the easiest one for you. They've chosen the easiest one for you over here. It's okay. They've chosen the easiest one, but we can handle difficult ones also with this much information. Yes, with this one information, you can handle the extra ones as well, right? If you are feeling adventurous, more adventurous than this, and you want to go a step further, then you can also think of drawing the graph of this. Ooh, the graph of this, yes. Based on definitions in different definitions and different intervals, you can draw the graph, and I'll give you the answer for verification. Verification, yes, so that you can verify your answer. This and this, this and this. This is the shape of the graph. This here is minus 1, this here is plus 1. So the values of x will lie from minus 1 to 1. And that is the actual domain of this. Domain of sin inverse 3x minus 4x cube will be from minus 1 to 1. Definition will change at minus 1 by 2 and 1 by 2. Those are the points at which definition changes. Right. And yes, obviously, NCERT people have chosen the easiest portion, that is minus 1 by 2 to 1 by 2 for us. They've asked that question. But we can handle the difficult ones. And yes, you can try and draw that graph as well. If you're going ahead for JEE examinations and all, you should be able to draw that, right? So with all of this in our mind, The solution of this is clear. Let's move on to the next question.